Welcome back, students. We will continue discussing a few more board problems on trigonometry. So currently we are working on the sample and board problems. The first problem is cos A is equal to 2 by 5. Find the value of 4 plus 4 tan square A. See, there are two ways to solve this problem. One is from cos, you have got the value of adjacent side and hypotenuse. And you can find the value of the opposite side by using Pythagoras theorem. And then by using opposite side by adjacent side, you can find the value of tan and substitute the value of tan in this equation and solve it. But the alternative method, what I'm going to discuss, uses trigonometric identity 2. It is more efficient and simple to solve. See, whenever you see some pattern like this tan square coming, it is related to trigonometric identities 2. So we take 4 plus 4 tan square A. I'm removing out 4 outside. Now it becomes 1 plus tan square A. According to trigonometric identity 2, 1 plus tan square A is equal to sec square A. So I put 4 into sec square A. Sec is nothing but inverse of cos. So this equation subsequently becomes 4 by cos square A. You have been given the value of cos square A here. So you are going to substitute here. So 4 by 2 by 5 the whole square. Now solving it, this becomes inverse. 25 goes up. We have this 4 here. This 5 square 25 here. Another this 2 square 4 here. Upon simplification, you have the answer 25. Now problem 2. If k plus 1 is equal to secant square a into 1 plus sin a into 1 minus sin a, then find the value of k. So when you see this two forms, you should relate that this is trigonometric identity 1. Kindly refer my video 9 to familiarize yourself on the different forms of the trigonometric identities. This is nothing but related to sine square theta plus cos square theta is equal to 1. It is one of the alternative forms. So you'll be using this format to solve this problem. So using trigonometric identity 1, this 1 plus sine a into 1 minus sine a becomes 1 minus sine square a, which is nothing but cos square a. So I'm going to substitute that here. K plus 1 is equal to secant square a. This whole 1 plus sine a into 1 minus sine a becomes 1 minus sine square a, which is nothing but cos square a. So k plus 1 is equal to secant square a into cos square a. Cos and secant have inverse relationship. So now either you can put sec by is equal to 1 by cos, or you can put cos is equal to 1 by sec. So secant square a into 1 by secant square a is equal to 1. We have now k plus 1 is equal to 1. Solving this, you get the value of k as 0. Problem number 3. Prove that 1 by 1 minus tan square a by 1 plus tan square a is equal to cos square a minus sin square a. See, whenever you see problems like this, and particularly when you see the square terms, you must have a trigger that it is related to a trigonometric identity. Whether it's related to trigonometric identity 3 and 2, it is 2, not 3. I'm sorry, it is 2. This is related to 2. Tan square plus 1 is equal to secant square. This is somewhere related to trigonometric identity 2. If you see this, it might look like trigonometric identity 1, but it is not so. Identity 1 is sin square plus cos square is equal to 1. Whereas here you have cos square minus sin square. So this is nothing to do with trigonometric identity 1. So let us see how to solve it. 1 plus tan square a by 1 minus tan square a by 1 plus tan square a. I am going to apply the trigonometric identity 2 here. So 1 minus tan square a becomes is to remain the same in the numerator, and denominator becomes secant square a. Now I am splitting the equation with the denominator, like when a plus b by c is equal to a by c plus b by c. Same way I am going to split the denominator, like 1 plus 1 minus tan square a divided by secant square a is equal to 1 by secant square a minus tan square a by secant square a. 1 by secant square a is nothing but cos square a, and tan square a by secant square a, when you simplify it, when you substitute the value of cos here, tan is sine by cos, tan is sine by cos, and secant is 1 by cos. Cos gets cancelled, and you are left with sine square. So you have proved that this equation left hand side is equal to right hand side. So problem number 4. It is saying prove that 1 by 1 plus sine a plus 1 by 1 minus sine a is equal to 2 secant square a. See, when you see the denominator, you have again the trigonometric identity 1. Identity 1, one of the forms. One of the forms is 1 plus sine theta into 1 minus sine theta is equal to cos square theta. So we have in the denominator 1 plus sine a, and another denominator you have 1 minus sine a. So when you try to add it, you end up multiplying both, and thus you have an opportunity to apply the trigonometric identity 1. So you are going to use the trigonometric identity 1. So and now I'm going to add both the equations. When I add, in the denominator you have 1 plus sine a into 1 minus sine a, and on the numerator this 1 minus sine a goes here, plus 1 plus sine a goes here. Now adding both, the sine a and sine a gets cancelled. On the numerator you are left with 2. Denominator you have 1 minus sine square a, and applying the trigonometric identity 1, it becomes cos square a. Cos square a is nothing but inverse of sec, so it becomes 2 secant square a, which is nothing but your right hand side. So now we move to problem 5. It says root 2 into sine a is equal to 1. Find the value of secant square a minus cosec square a. So now which trigonometric identity can I use? See, when I consider this term, it looks like trigonometric identity 2. When I see cosec, it looks like trigonometric identity 3. But both are coming in a single equation. So this cannot be related to trigonometric identities. But however, you have the value of sine a as 1 by root 2. So you have now two ways to solve this problem. One way is you have here the opposite side, you have here the hypotenuse. So you can find out the adjacent side. Adjacent side is again going to be 1 actually. When you do the Pythagoras theorem, we're going to get it as 1. Then using the opposite side, hypotenuse, and adjacent side, we can substitute the values of sec and cosec and solve the equation. That is one way. Another way, what I would suggest always to check first is always check whether this corresponds to standard trigonometric angles. Like for what angle of A will sine A give you 1 by root 2. So sine A becomes 1 by root 2 when the angle of A is 45 degree. So with this approach, we will try to solve this problem. Sine A is equal to 1 by root 2, which is nothing but sine 45. We have the value of A as 45 degrees. Now you substitute this 45 degree in the place of A. So the equation secant square A minus cosec square A becomes secant square 45 degrees minus cosec square 45 degrees. The value of sec 45 is root 2. So I am putting the whole square, and the value of cosec 45 is also root 2. So I am squaring both. You get 2 minus 2 is equal to 0. So in the next video, I will talk about some common mistakes, tricks, and tips to solve the problems of this chapter. Thank you and bye till then.